Today we want to determine the set of all binary and homogeneous relations on M. M is the set of A and B. Woo! Relations! To do this, you need a basic understanding of sets, subsets and relations. But even without that, you can try to follow this solution. First of all, I want to clarify the terms binary and homogeneous to make it easier to solve and understand the task. Binary means that the relations consist of pairs. One element is related to another. Then the next two elements are related to each other and so on. In binary relations, the number of pairs does not matter. It is only important that they are pairs. In R1, A is in relation to B. This is a binary relation because it's a pair. R2 is the same thing with other elements and two pairs. R3 is a relation of numbers, also a binary relation. R4 is not a binary relation. As you see, it contains triples. This means that three elements are in relation to each other. Binary relations are used 99% of the time when discussing relations in math. But most of the time it won't be mentioned in the task. The same facts apply for the property homogeneous. A homogeneous relation will face elements from the same set. That means it will relate to just one set. In our task, this is M with a set of A and B. In homogeneous relations, the type of relation, for example pairs or triples, doesn't matter. It's only important that the elements that are in relation to each other are elements of the basic set. This is M in our case. R1 is a homogeneous relation on M. R2 is as well a homogeneous relation on M, this time with triples. R3 is no homogeneous relation on M because one of its pairs contains a C, which is no element of M. But R3 is a homogeneous relation on, for example, a set of A, B and C or A, B, C and D. So whenever someone says this is a homogeneous relation, it has no value at all. Important is that you say on what set the relation is homogeneous. This makes sense, doesn't it? Both of the properties are easy to understand. So hopefully you are now able to solve the whole task. To build the set of all binary and homogeneous relations on M, we first of all build all relations on M. R1 to R4 contain one pair each. R5 to R10 contain two pairs each. R11 to R14 three pairs. And finally R15 all four possible pairs. R16 is the empty set. This is part of the set of all relations because I could define a relation on M that won't fit for any of the pairs in R15. For example, R16 is the relation where the first element is bigger than the second. We can define our relations as we want. In this case, the elements of M are letters. Letters can't be bigger than other letters. So A isn't bigger than B, and B isn't bigger than A. Neither is A bigger than A or B bigger than B. So the relation has no elements. This results in the empty set. The correct solution of this task needs to be one set. We grab all our 16 relations, separate the sets with commas, and finally put them in curly braces. Now we have one big set of all binary and homogeneous relations on M. In your exam, you may need to be faster. For a quick and smart solution, you need a bit deeper understanding of cross or Cartesian products, power sets, and cardinality. We build the cross product of M with itself. This is a set of all four possible pairs. The power set of our cross product is the final solution to our task. The power set contains all possible subsets of the cross product. In our case, this is all possible relations. We can check this by determining the cardinality of the power set of the cross product, or the cardinality of the solution, or even easier, the amount of sets in our solution. As we see, this equals 16, which is the amount of our 16 relations R1 to R16 from the previous solution.